oxygen is one of the most chemically violent, corrosive gases in the universe. For most of Earth's history, oxygen was practically absent from our atmosphere. When it first appeared about 2.4 billion years ago, it caused the largest extinction event our planet has ever seen. We call it the Great Oxidation Event, and it wiped out most life on Earth at the time. But here's the fascinating part. That catastrophic poison became the foundation for complex life, and it created something else, a massive, glowing beacon visible from across the galaxy, a signal that screams to any advanced alien civilization, there's life here. Let's explore what might happen if an alien civilization detected Earth's oxygen and decided to investigate. The optimistic scenario involves what we might call cosmic scientists. These would be aliens driven by curiosity, not conquest. They'd approach Earth the way we'd approach an exoplanet with biosignatures, carefully, scientifically, trying to understand what kind of life produces all this oxygen. In this scenario, they might have been observing Earth for millennia, watching our biosphere evolve. Research from the SETI Institute suggests that any civilization capable of interstellar travel would be at least thousands of years more advanced than us. They'd likely have overcome resource scarcity, tribal conflicts, and existential risks that threaten young civilizations. Astronomer Jill Tarter, who spent decades leading SETI research, argues that aggressive civilizations probably destroy themselves before achieving interstellar capability. The same technology that enables star travel also enables self-destruction. Only mature, peaceful civilizations survive long enough to explore the galaxy. If that's true, first contact might be gentle. They might send probes, study our ecosystems, perhaps even attempt communication. The challenge would be mutual comprehension. How do you explain oxygen-breathing biochemistry to beings who might metabolize methane or exist as electromagnetic patterns in plasma? But there's a darker possibility. What if oxygen isn't just interesting to aliens? What if they need it? What if, by cosmic coincidence or convergent evolution, alien life evolved to depend on oxygen chemistry just like we did? A 2020 paper in the journal Astrobiology explored this possibility. The authors argued that oxygen-based metabolism might be common in the universe because it's so energetically efficient. Oxygen enables complex multicellular life because it produces vastly more energy per molecule than alternative metabolisms. If that's true, Earth wouldn't just be interesting to oxygen-breathing aliens. It would be valuable, critically valuable. Imagine a civilization that's exhausted their planet's oxygen, facing extinction. They scan the galaxy and find Earth, a world with abundant oxygen, similar gravity, compatible temperature ranges. We wouldn't be fascinating neighbors. We'd be a resource to be harvested, or worse, displaced. Now let's think through the mechanics of an alien civilization actually coming to Earth for our oxygen. First, the good news for humanity. Interstellar travel is absurdly difficult. The nearest star system, Alpha Centauri, is 4.37 light-years away. With our current fastest spacecraft, it would take about 100,000 years to get there. Even if aliens have technology 1,000 times better than ours, that's still a century of travel. The energy requirements are staggering. Physicist Robert Zubrin calculated that accelerating a 1,000-ton spacecraft to just 10% the speed of light would require energy equivalent to all the electricity the United States produces in an entire year. And that's just for acceleration. You need the same energy again to decelerate. For aliens to reach Earth, they'd need either generation ships that sustain populations for centuries, suspended animation technology, or something we can't even imagine yet, like faster-than-light travel or wormholes. But here's the thing. If they've mastered interstellar travel, they've already demonstrated technological capability far beyond ours. The same civilization that can cross light years of empty space wouldn't be stopped by anything we could throw at them. Consider the military implications. Our most advanced weapons, Nuclear missiles, fighter jets, aircraft carriers would be useless against a civilization that can manipulate space-time or harness stellar energy. It would be like ancient Romans trying to fight modern tanks with swords and shields. Even biological warfare would be questionable. An alien species might have completely different biochemistry. Earth pathogens might not affect them at all, just as our viruses don't infect plants or bacteria. Astrophysicist Stephen Hawking famously warned against trying to contact alien civilizations, comparing it to indigenous peoples encountering European colonizers. The technological gap ensured the outcome was catastrophic for the less advanced civilization. History suggests that when two civilizations meet with vast technological differences, it rarely ends well for the weaker party. But there's another angle to consider. What if they don't need to invade at all? Here's a scenario that keeps astrobiologists up at night. What if aliens could simply take our oxygen without landing? Earth's atmosphere extends hundreds of kilometers into space. The exosphere, the outermost layer, gradually fades into the vacuum of space. Atoms and molecules naturally escape into space all the time. We lose about 90 tons of atmosphere daily through this process. An advanced alien civilization could dramatically accelerate this loss. Theoretical methods include electromagnetic harvesting, using powerful magnetic fields to strip oxygen ions from the upper atmosphere. This isn't science fiction. We already observe this happening naturally. Mars lost most of its atmosphere because solar wind stripped away its gases over millions of years after Mars lost its protective magnetic field. Research published in Science in 2017 confirmed that Mars loses about 100 grams of atmosphere to space every second. An artificial system could be far more aggressive, position massive electromagnetic collectors in orbit, create a directed flow of oxygen into collection vessels, and transport it away. To humanity below, it might appear as unusual aurora activity at first. By the time we realized what was happening, it could be too late. Gravitational manipulation. This is more speculative, but within theoretical physics. If aliens could manipulate gravity, and some interpretations of general relativity suggest this might be possible with exotic matter, they could create a localized reduction in Earth's gravitational pull on atmospheric gases. Oxygen would simply drift away into space at accelerated rates. The terrifying part is we might not even notice at first. Earth's oxygen levels fluctuate naturally. A 1% decrease wouldn't cause immediate problems, but it would be the beginning of a death spiral. According to research from the University of Colorado, if Earth's oxygen dropped below 19%, we'd start seeing serious health impacts: impaired cognition, increased heart rate, respiratory stress. Below 15%, survival becomes impossible for most mammals. Plant life would struggle to compensate, but there's a limit to how fast photosynthesis can occur. If oxygen was being stripped away faster than biology could replace it, we'd face an extinction event in slow motion. Years or decades of gradually worsening air quality, increasing illness, ecological collapse. And here's the cruel irony. The very thing that makes Earth valuable to oxygen-seeking aliens, our biosphere's ability to generate oxygen, would be destroyed in the process of harvesting it. So what could humanity possibly do if Earth's oxygen attracted hostile alien attention? Our first and best option would be diplomacy. Organizations like the SETI Institute have developed protocols for potential alien contact. The principle is simple: demonstrate intelligence, non-hostility, and willingness to communicate. The 1972 Pioneer Plaques and 1977 Voyager Golden Records were humanity's first attempts at interstellar messaging. They contain information about Earth, humanity, and our culture, designed to be interpretable by alien intelligence. Carl Sagan, who led the Voyager project, believed that any civilization capable of receiving the message would be peaceful by necessity. But what if diplomacy fails? What if the aliens view us the way we view bacteria in a petri dish? Interesting, but ultimately expendable. Our defensive options would be limited, but not zero. Some scientists have proposed Atmospheric cloaking. If we detected alien observation decades or centuries before arrival, we could theoretically try to mask our biosignatures, burn massive amounts of oxygen, pump out different gases, create artificial signals that confuse spectroscopic analysis. This would be monumentally difficult and might damage our own biosphere, but desperation breeds creativity. Satellite defense networks. Physicist Michio Kaku has proposed that humanity should develop orbital defense systems, not for asteroids or missiles, but for potential alien threats. High-energy lasers, kinetic projectiles, even nuclear weapons deployed in space. These might not stop an advanced civilization, but they demonstrate we're not defenseless. Underground preservation. If we couldn't prevent oxygen theft, we could try to survive it. Massive underground habitats with artificial atmospheres, sealed biospheres, cryogenic preservation of genetic material. Essentially wait out the invasion underground and hope to rebuild afterward. But there's a more hopeful possibility based on game theory and economics. In 2018, researchers at the University of California published a fascinating paper applying economic principles to alien contact. Their conclusion: if aliens need oxygen, Earth is valuable not just as a source, but as a factory. Our biosphere continuously produces oxygen. Destroying that factory would be economically irrational. They might instead propose a trade. They protect Earth from cosmic threats like asteroids or solar flares, and in exchange, we allow controlled oxygen harvesting at sustainable levels. It would be colonialism, certainly, but potentially survivable colonialism. This assumes aliens think like economists. That's a big assumption. To understand why oxygen would attract aliens, we need to understand what makes it special. In the universe's natural state, oxygen doesn't exist freely. It's too reactive. Oxygen atoms desperately want to bond with other elements. That's what burning is, rapid oxidation. That's what rust is, slow oxidation. Left to its own devices, all the oxygen in Earth's atmosphere would disappear within a few million years, binding with rocks and metals. So why do we have an oxygen-rich atmosphere? Because life constantly replenishes it. Photosynthetic organisms, plants, algae, cyanobacteria, split water molecules using sunlight, releasing oxygen as waste. They've been doing this for billions of years, pumping out roughly 330 billion tons of oxygen annually. Without life, Earth's atmosphere would look more like Mars or Venus, mostly carbon dioxide, practically no free oxygen. This makes oxygen what scientists call a biosignature, a chemical indicator of life, and it's not subtle. In 2019, astronomers using the European Southern Observatory calculated that Earth's oxygen signature would be detectable from over 100 light-years away using technology only slightly more advanced than our current telescopes. NASA's James Webb Space Telescope, launched in 2021, is designed to analyze the atmospheres of exoplanets by measuring how starlight filters through their atmospheres. Different molecules absorb different wavelengths. Oxygen has a distinctive absorption pattern in the infrared and visible spectrum. Sarah Seeger, an astrophysicist at MIT and pioneer in exoplanet research, has cataloged thousands of potential biosignature gases. Oxygen consistently ranks as one of the most reliable indicators of biological activity. She stated that finding oxygen in an exoplanet's atmosphere would be the holy grail of astrobiology. Now, flip the scenario around. If we can detect oxygen on distant worlds, advanced alien civilizations could certainly detect ours. In fact, they've had 2.4 billion years to notice it. Which raises an uncomfortable question. If they noticed, why haven't they visited? The scenario of Earth's oxygen attracting alien life forces us to confront our place in the universe. For billions of years, our biosphere has been broadcasting its presence to the cosmos through the oxygen signature. Every breath you take is part of that signal, rippling out through space at the speed of light. If alien civilizations exist and are looking, they've likely already noticed. The fact that they haven't visibly arrived might mean several things. They don't exist in our cosmic neighborhood. Interstellar travel is harder than we imagine. They're already here, and we haven't recognized them. Or they're following some form of cosmic non-interference principle, a prime directive like in Star Trek. Or maybe the universe is full of oxygen-rich planets, and Earth isn't special at all. Recent exoplanet research suggests there could be billions of potentially habitable worlds in our galaxy alone. Perhaps oxygen is common enough that nobody needs to travel 100 light-years to find it. But this thought experiment reveals something important about how we think about life in the universe. We tend to imagine aliens as either benevolent explorers or hostile invaders. The reality might be far stranger. Beings with motivations, needs, and ethics so different from ours that we can barely comprehend them. What we do know is this: our oxygen atmosphere is both Earth's greatest gift and potentially its greatest vulnerability. It enabled complex life, allowed consciousness to emerge, created the conditions for civilization. But it also makes us visible, identifiable, and possibly valuable to unknown observers. So the next time you take a deep breath of Earth's oxygen-rich air, remember, you're not just breathing. You're participating in a planetary signal that's been transmitting for over 2 billion years. And somewhere out there, someone might be listening. Thanks for watching. If this exploration of astrobiology and alien contact scenarios expanded your view of the cosmos, hit that like button and subscribe for more journeys through science's biggest what-ifs. Until next time, keep imagining.